Okay, so we're gonna start on page 7 as your warm-up. Let's just do it together. Okay, so in the previous task, we used the similarity of circles, the symmetry of circles, and right triangle trig, and proportional reasoning to locate stakes on concentric circles. That's what we did yesterday. In this task, we're going to consider points on the simplest of circles, the circle with the radius of 1, which for short we call the unit circle because the radius is 1 unit. Here is a portion of that circle. And it's in the first quadrant, and we've divided it using pi over 8 radians. Find the coordinates of each indicated point in the diagram. And then we're going to find the arc length. So this is going to be some x, y. So if I make that into a triangle, here's that angle of pi over 8. I know we don't love radians yet, we're just getting used to them. So let's think of that in degrees like we did our Ferris wheel. 180 divided by 8. So this is 22.5 degrees. Let's just do this one while we're at it. 45 degrees. 67.5 degrees, and up here we're at 90 degrees. Okay, so if I want to find this x and y, we'll use 22.5 degrees. We're going to say cosine 22.5 is x over r, and sine of 22.5 is y over r. Oh, okay, I'm in degree mode. So that is 0.92 and 0.38. Because the radius is 1, if I sine cosine every angle, I'm going to get these coordinates. Oops, down here. Well, this is a quadrantal angle. It's over 0 and up 1 because it's the radius. Okay, so we've got all of our coordinates. Now we need the arc length. Okay, arc length is, let's do, okay, it's a portion of your circumference, and it's your angle out of 360. So circumference is 2 pi r, 2 pi times the radius. Let's just do, we'll do 45. So the arc length at 45 is 2 pi times 1 times 45 out of 360. Now I'm going to do this exact. I'm not going to do anything with the pi. And notice we get pi over 4 because 2 times 45 over 360 reduced to 1/4, so 1 pi over 4. Let's do that again here. 2 pi times the radius. What fraction of the whole circle? Interesting. What do you think we'll get as the arc length up here? Let's see. 67.5 out of 360 times 2, because it's 2 times pi r. Math, enter, enter gets me a fraction. Oh, it's 3 pi over 8. Fascinating. Okay, did we do all the directions? Yes. All right, on the back, page 8. Javier's been wondering if his calculator will allow him to calculate trig values for the measures in radians rather than degrees. He thinks this would make his life a lot easier. Well, let's see. If you go to mode and change to radian, hit enter on radian, quit. If I type sine of pi divided by 8, whoops, I would expect it to give me, sorry about the jumping, 0.38, because that was the sine, was the y coordinate. Does it? It does. Okay. What if we did cosine of pi over 8? It does. Sorry, there's a glare. Well, let's try pi over 4. It does. It's working. Okay. So let's go back to page 8 and see what he says. Record your values as approximations. Okay. 0.38. Oh, thousandths. 3.29. Oops. 0.924. 0.707. These were the same. The coordinates and arc lengths you found for points of the unit circle seem to be showing up in Javier's computations. Why is that so? Explain why the radian measure, or why is that, okay, that is, explain why the radian measure of an angle is the same as the arc length. Okay, the radius is the arc length divided by the radius. Oh, sorry, radians, sorry, yikes. We saw yesterday. Radians is the arc length divided by the radius. Well, when the radius is 1, we get the arc length because the unit circle is radius of 1. So sorry, I go back and make sure you have radians from yesterday. Radians equals arc length divided by radius. Explain why the sine is the same as the y coordinate. So sine of theta is y over r, but in the unit circle, the radius is 1, so sine equals y. What about cosine? That's going to be x over r, and x is 1. Okay, we're not doing this. Instead, I want to talk about some other notations. We're going to fit it in down here. If we have cosine of pi over 4 squared, mathematicians like to write that as an abbreviation this way. When it says cosine squared of an angle, that means the whole quantity squared. That's different than cosine of pi over 4 squared. That's just squaring the angle. That's not the same as these. The reason I'm bringing that up is now on the next page, it says compute each of the following. So you're going to use your calculator. This is page 9. We'll pause the video here. You type these in, but you're going to have to type it like this to figure out what you're going to equal. Okay, we'll pause. You can't type it. What do you get? For every single answer, you should have received the value of 1. Okay, number 5 says, what do you notice? What do you number? Or what do you wonder? Not what do you number. They're all 1. But why is that? Let's see why. It says, make a conjecture about cosine squared theta plus sine squared theta. Where theta is the same angle here, cosine squared theta plus sine squared theta will equal 1. Let's see how we can prove that. Let's start with a right triangle. We'll do the unit circle again with x, y, and 1. Pythagorean theorem from geometry was a squared plus b squared equals c squared. So from this picture, we get x squared plus y squared equals 1 squared, which is 1. But we saw earlier, instead of x, from the unit circle, that's the same thing as cosine of theta, because cosine of theta is x over 1. But don't forget the squared. And y is the same thing as sine of theta. So there you got it. Cosine squared plus sine squared equals 1. So the theorem, Pythagorean theorem, is a squared plus b squared equals c squared. The Pythagorean identity is cosine squared theta plus sine squared theta equals 1. This Pythagorean identity you must memorize. Ooh, it's a 1. Will it work for degrees or radians? What do you think? Yes. As long as you use the same angle. Because it's theta, theta. It's referencing the same angle. You can't make this, like up here, cosine squared of 90 plus sine squared of 45. They have to be the same degrees or the same radians. All right, so we're gonna practice using the Pythagorean identity on page 10. So let's start A together. I'm gonna slide up a little bit. See how it says theta is in quadrant 1? I'm gonna draw myself a little triangle. No, I'm not. I'm not gonna use, sorry. What I'm gonna do is just draw my little memory that all functions are positive in quadrant 1, sine, tangent, and cosine. So then for A, I know that cosine squared theta plus sine squared theta equals 1. For all of these problems, we have to use the Pythagorean identity because that's what your homework says. That's what the test and quiz are gonna say. So cosine squared theta is the same thing as cosine theta squared. And cosine's 3/5. So now I can square the 3/5. I'm gonna subtract the 9/25 to the right. Uh-oh, so this is 25/25. So 25 minus 9 is 16/25. If you're not sure and you wanna do some arithmetic this way, math, enter, enter. And I can square root both sides, and I get sine of theta is 4/5, plus or minus. But I decide the plus or minus based on the quadrant. So in quadrant 1, sine is positive. Okay, let's do B together, and then we'll pause the video for you to do the rest. Cosine squared plus sine squared equals 1. I don't know cosine. Sine squared. Okay, sorry. So I get cosine squared plus 9/25 equals 1. Subtract the 9/25 again. Just like this one. Just like part A. So cosine is plus or minus 4/5. But quadrant 3, oops, sorry, cosine is negative, so that's how I know that's negative 4/5. Okay, we'll pause the video here. You try C through H. That way you get some practice, check with your table, and then when you unpause the video, oops, focus. When you unpause the video, I will write all the answers in. For C, you should have gotten 12/13. Sine is positive in quadrant 2. For D, you should have gotten 24/25. Quadrant 4, cosine's positive. E, √3/2. F is negative √3/2. G is 1, and H is 1. Negative 1, because between 90 and 270. So that's over here, and the x-coordinate on that quadrantal angle is -1. It's to the left of the origin. This one is here, and it's above the origin, so it's positive sine. Okay. Your homework is page 11. You can ignore these triangles down the side. I don't know why they're there. You must use the Pythagorean identity on all these problems. You definitely need separate paper. There's not enough room here. You can do the back, but that just requires a lot of flipping. So your job, page 11, we'll check it tomorrow. Don't forget to check your answers on Drive.